So I mentioned this several times, and that is the system memory layout for stack versus heap. Now, by the way, this dynamic data, that's the heap memory. Okay, so I'm going to see me cross that out and put heap in there. They both share a memory portion of your computer that's going to be probably interchanged quite a bit because you're doing different things on your computer. You're playing games. You're doing other than what you should be doing. You know, all these different things. And all that stuff takes up, the applications take up memory in both aspects. But they work together as in that's the memory that's going to be used for your computer for various applications. The rest of it is code, is data, it's reserved for your OS, all these different things that are really important. Now, when we're using the stack portion of the computer memory, the stack is going to shrink and grow. Also, it's worrying about the local scope of variables because we talked about that before in memory diagrams, and we talked about that in the call stack. That's really what the stack is going to be taking care of. But when we're doing some type of function calls and some other areas like that, we know that they're going to relatively disappear rather quickly, so that's where the stack is taking care of it. Now, this is a very limited space, and it has automatic garbage collection because, again, it knows it's going to be called in and called out quickly. The heap portion, which is the dynamic portion, that's an area for sorting large amounts of data or dynamic objects. So these are going to be not just your arrays, but they're going to be your objects, your array of objects, your larger data types that you're going to hold. So these are function calls and local variables, stuff like that. This is a much bigger section. So it's going to be a nice flexible area because eventually we're going to be getting into vectors and other data structures that you'll have in either this class or the next class. And they take up a lot of memory because your application is going to require a lot of memory to store all the data. So it's, again, very different on the dynamic data or heap data area of what exactly that's going to be doing. Now, when we're using the heap portion of the computer memory, this has to be allocated and deallocated. I already showed you some code about that. Otherwise, frankly, it sticks in there, and you've had computer games and stuff like that where it wasn't very good at memory management. Didn't your computer eventually start slowing down or something of that nature? I've played Civ 6. I've played a lot of big games and City Skylines. The memory just goes to hell in a handbasket anyway. Even Minecraft once in a while. But anyway, we have to deallocate and allocate it. But it does not have automatic garbage collection because, again, really, this part is under our control. There's no call functions or call stacks or anything else like that. This is the data that we really wanted to look at so we can have our applications work. So we have to get rid of the garbage, and that's the deallocation. And then one of the keywords that we're going to have is the new code needed in C++, the new and double quotes, and then new as in new to dynamic arrays code, and I'm going to go over a little bit more of that later. So that's what the heap is doing compared to the stack.